Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about span a set of vectors. This is very important class in order to understand the concepts of linear algebra. So this is very important and little bit confusing to understand. Watch it multiple times until you get the clarity. Most of the visualization which we show here, that is very important. So now let's try to understand what is meant by span a set of vectors. In our last class we discussed about adding a scalar to a vector, multiplying a scalar to a vector and adding two vectors. What will happen? The graphical intuition we already provided in our previous class. Please watch that class and come back here. The link for the playlist is provided in the description below. Now coming to, let's take a two-dimensional space. Means it's a plane. Two-dimensional means it's a plane. On this two-dimensional space, if you are given a vector, 2, 3 is a vector. How it looks like? This looks like, the vector looks like this, 2, 3. Means it is moving 2 units towards x-axis and 3 units towards y-axis. So it is 2, 3. This is how this pink line, we call it as the vector 2, 3. So spanning here means spanning a set of vectors. The set of vectors that are provided here is only the single vector it is provided. You are provided with a single vector. So what this vector is going to span means, suppose if you multiply this vector with a scalar, means 2 multiplied by 2, 3. That is 4, 6. You got a new vector. See, this new vector is in the same direction, but length increases. So 4, 6 is a new vector which you got from 2, 3 by multiplying scalar. But it is not changing the direction. It is increasing its length. Means you got a new vector up to here. Similarly, if you multiply, see, now you got two vectors which are moving in the same direction. 2, 3 is a vector which is moving in this direction. 4, 6 is a vector which is moving in the same direction. Adding these two vectors, what happens? 2, 3, 4, 6. Adding these two, you are going to get 6, 9, which will move in the same direction. So 6, 9 will be somewhere around here. Means the point you need to understand, adding two vectors that are moving in the same direction, you are going to get a new vector that moves in the same direction. So you got a new vector 6, 9 somewhere around here, which is moving in the same direction. Means here spanning means by giving this 2, 3 vector, what is the space that you are able to occupy, means you are able to span. So from 2, 3 you can move up to here 4, 6 by multiplying with scalar. By adding these two vectors, you are going to get a new vector which is somewhere around here, which is in the same direction. Means by using this vector, I am able to span the space that belongs to this line. This is a line, right? The line moving in this direction. This entire line I can span. Means by applying the basic vector operations. What's those operations? Multiplying with the scalar, adding two vectors. By using that concept, by doing that operations, I am able to span the line that belongs in this direction. So using this vector, I am able to span a line that moves in this direction. See, you check one more point. When you multiply 2, 3 with -1, means you are going to get a vector here, -2, -3. On the same line in the opposite direction. When you add -2, -3 plus 2, 3, these two vectors we are able to span. By adding these two, you got 0, 0. Means this line is passing through origin. Like that, if you want to move this way, multiply with negative numbers, you are going to get this way. If you want to move the other side in the same direction, multiply with the scalar. So this is what we are going to span using this vector. We are able to span a space that belongs to a line. We are able to span a space on this line. That is what spanning a set of vectors means. And not yet completed. Now this is very important. Now you are given two vectors, means your set contains two vectors. -1, 2 is one vector and 2, 3 is another vector. 2, 3 moving in this direction. -1, 2 moving in this direction. Suppose if you are given two vectors that moving in two different directions, what is the space that you are able to span? Means multiply this -1, 2 using a scalar. Suppose if you multiply with 2, -2, 4 means you will get a vector that is somewhere around here. Suppose if you multiply this with a scalar 2, 3 with 2, 4, 6, you are going to get somewhere around here. Suppose if you add these two vectors, what happens? In our last class we provided the intuition how adding means. -1, 2 when you add means, when you add with 2, 3 means this moving 2 units towards x-axis and 3 units towards y-axis. Adding -1, 2 means from here move 1 unit backwards, -1 on x-axis, and 2 units above on y-axis, somewhere you are going. So if you add this means bring it to here. You are going to get somewhere the point here. Because it was given two vectors that are moving in different directions. So what is the space that you are able to span by using these vector operations? Adding, multiplying with scalar. Suppose if you increase this, somewhere you are going to point here. Means if you multiply with scalar with 2, -2, 4, you are going to get somewhere point here. If you add this vector -2, 4 with this, you are going to get somewhere point here. If you increase, if you multiply this with scalars, it is moving up to here. If you multiply with 2, 4, 6, somewhere vector here. Adding -1, 2 to 4, 6 means 4, 6 add -1, 2. You are going to get a point here. Means by using these two vectors, you are able to move to any point on this entire plane, this two-dimensional plane, by doing vector algebra operations. What are those operations? Multiplying with scalar, adding two vectors. By using multiplying with scalar, adding these two vectors. You can move here, you can move here, you can move here. Multiply with a scalar, somewhere you are going to get here. Add it with this 2, 3, you are going to get here. The same way, if you want to move in this direction, multiply with a negative number. This 2, 3, multiply with a negative number, you are going to this side. Add with -1, 2, you are moving this side. So by giving two vectors that are moving in two different directions, you are able to span this entire two-dimensional plane. Similarly, the next concept is also important. Spanning, what happens during spanning, the graphical intuition which we provide here in three-dimensional space, it is also important. Suppose take a three-dimensional space, x-axis, y-axis and z-axis. Z-axis should be like this. This is what z-axis is. Three-dimensional space. If you are given a vector 2, 3, 5, 2 units towards x-axis, 3 units towards y-axis and 5 units towards z-axis, means your vector will be somewhere around here. This is how your vector will be. But we are unable to show it on the board. That's why 2, 3, 5 is written like this. This is how it was shown, 2, 3, 5. But actually your vector is like this. If you multiply this vector with a scalar, it will move up. If you multiply with large number, it will move up in this direction from here to this side. Similarly, if you multiply with a negative number, this will go the other side. This is what your vector 2, 3, 5 in 3-dimensional space. So if one vector is given, what is the space that you are going to span? You are going to span by using this vector. You can move on any point on this line in 3-dimensional space. Line in 3-dimensional space. This is a line in 3-dimensional space, which moves the other side also. Similarly, suppose if you are given two vectors in 3-dimensional space, 2, 3, 5 is one vector, -1, 2, 4 is another vector. See here, 2, 3, 5 is moving in this direction in 3-dimensional space. Similarly, -1, suppose take this, 2, 3, 5 is moving in this direction, and -1, 2, 4 is moving in this direction. By using these two vectors, what is the space that you are able to span? By multiplying this 2, 3, 5 with a scalar, you can move in this direction. By multiplying this -1, 2, 4, you are able to move in this direction. By adding these two means get it up to here. This is what adding means. See, this is what adding means. You can move in this direction. So now, what is the space that we are able to span by using these two vectors in 3-dimensional space? Let's try to understand with suppose these two vectors are like this. This is 2, 3, 5, and this is -1, 2, 4. So these two vectors are on a plane. This is a plane in 3-dimensional space. Suppose if this vector has changed, change it to -1, 2, 4. The plane will also change. It will be like this. This is another plane. This is another plane. This is another plane. So 2, 3, 5 and -1, 2, 4. If you multiply 2, 3, 5 with a scalar, this is going to move like this. If you multiply -1, 2, 4, this is going to move like this. Adding these two, you are going to do this addition, means you are going to get a point, means the vector on this plane. So by using these two vectors that is moving in two different directions in 3-dimensional space, you are able to span space that belongs to a plane, this plane. Means you can cover all the space. We can move on to any point on this plane by using these two vectors, by applying vector algebra operations, means addition of vectors and multiplying with scalar. That is what spanning a set of vectors. And the last point you need to understand, suppose if you are given three different vectors that are moving in three different directions. 2, 3, 5 is one, -1, 2, 4 is another one. By using these two, you are able to span a plane. Okay, like this. Suppose if you are given a new vector, another vector, -2, -1, 6, this point is above this plane. Means on this plane too, this vector is moving in this direction, in the 3rd dimension. So by using these three vectors, by adding these three vectors, you can move on to any point on the plane. Any point on the plane. Because by multiplying this vector with a scalar, you can move this. By multiplying a vector with this scalar, you can move like this. Adding these two, you are going to do like this, adding this 2. Adding this 2 with this vector, you are going to move a point above, third dimension. These two helping us to move on a plane like this. This is helping us to move to the third one, on the above. So you have to visualize this. So by using these 3 vectors, add these 3 vectors, you are going to get somewhere a point here. Multiply this vector with 2 and add these 3 vectors. Somewhere it is moving direction. Because you increased the size, you increased the length of this vector. Means 2, 3, 4. This is the vector. When you multiply with 2, you are going to increase the length. Adding the remaining 2, this is somewhere it is going to get like this. So hope you understand what is meant by spanning a set of vectors. Means you are given a set of vectors. Using this, you are going to span a line. You are given a set of vectors that are moving in 2 different directions. Using this, you are able to span the entire 2-dimensional space. Coming to 3-dimensional, in using this 3-dimensional, you are given a single vector in 3-dimensional. You are able to span a line space in a 3-dimensional space. Similarly, you are given 2 vectors on the 2 different directions. If both are in the same direction, you are not able to span. It will go in the same direction. 2 different directions. You are able to span a plane in a 3-dimensional space. Plane. As vector changes, plane changes. Similarly, you are given a 3 vectors that are moving in 3 different directions. You are able to span this entire space. Hope you understand what spanning a set of vectors means. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.